Okay, let's do another example of integration by parts. This is actually a really nice, sneaky one. We're going to find out how to do the integral of ln of x dx. And I say it's kind of a sneaky one because we actually, it doesn't look like it's an integration by parts thing here, right? I said that integration by parts is when you have a product of functions, and this isn't actually a product, right? So I just have a ln of x here. So if I was going to do the integration by parts, right, integral of u dv is uv minus integral of v du, what would be u and what would be v? Well, if I actually, so, and it doesn't look like you can do that, right, is the point. But really sneakily, and I think this is really cool, it sort of blew my mind when I saw this for the first time, u can be ln of x, which makes du dx equal to 1 over x, and du equal to 1 over x dx, and dv, this is a good time to pause the video and try to guess if you want to see if you can get this for yourself. I definitely didn't. But dv is actually going to be dx, which makes v just equal to x. So yeah, you can do that, right? You actually can do that. This is the same thing as saying that dv by dx, dv dx is equal to 1. And that would come from v being equal to x. So this thing, making the dv equal to dx, is actually a really cool, really useful trick. I use this in all sorts of places. If you want to find the integral of arctan and stuff like that, other tricky ones, you can do that, and it actually works. It actually is okay. So I can substitute these into the formula. I get integral of ln of x dx is equal to u, which is ln of x, times v, which is x, minus integral of v, which is x, times du, which is 1 over x dx. So this ends up being x ln x, it's usually written, minus integral of just dx, which is what? It's just x. So the integral of ln of x is x ln of x minus x, plus a constant, of course, but this is the important part. And we can check, and not a lot of people know this actually. Ln is the one that people who've been doing integration for a while, you ask them what's the integral of ln, and they just draw a blank. But I can actually check d by dx of x ln of x minus x plus a constant is d by dx of x ln of x minus d by dx of x plus d by dx of c, which is going to be, well, what's d by dx of x ln of x? Well, it's again product rule, d by dx of x times ln of x plus x times d by dx of ln of x minus derivative of x with respect to x is 1, and the derivative of a constant is 0 with respect to anything. So we go to the next line, d by dx of x is just 1, so it's 1 times ln of x plus x times derivative of x with respect to x of ln of x is 1 over x minus 1. And so I just end up with ln of x plus x over x is 1 minus 1. These cancel, and wouldn't you know it, it's just ln of x. So this is a really useful thing to know, that the integral of ln of x is x ln x minus x plus a constant, of course. And that also the main takeaway in terms of integration techniques is that the dx can be the dv. That's actually a thing you can do. It can actually be the dv, and that comes in really handy sometimes.